Hey, this is Mrs. Allen. I'm going to go ahead and do a video of this Nearpod from Tuesday for you because it seems like a lot of people were having technical problems that day. I apologize that there's this big chunk of stuff here. I don't know how to get rid of it, and I want to get this video out to you soon. So here we go. Let's just start. So the question is, how do we answer questions? So we're learning the steps of the scientific method to design an investigation, which is which household material is going to absorb water best, to answer that question. So we're going to write our own procedure for determining which household material can absorb the most water. I'm going to skip the poll. So the quick review of the steps we take: we make observations, we ask questions, we want to know when we're looking at the world around us why things happen the way they do, and we're going to conduct an experiment to find out a little bit more about that question. Before we make that experiment though, we want to research and gather information. So for example, in the reading you had on Tuesday morning, you found out that sometimes boiling water freezes faster than cold water. So you're going to want to do some research about why that happens, and what you'd find out is that people have noticed this over centuries, and what they found is this thing called the Mpemba effect, which is basically that is something that happens sometimes, that hot water freezes faster than cold. Okay, so you can check books, ask people. There's a world of scientific research that's been done and published in peer-reviewed journals, and that's a good place to find that stuff. After you've done your research, you're going to form a hypothesis to ask a question that's going to take that knowledge one step further. So we as a scientific community already know this certain amount of what's there. So you want to ask a question that's going to take it one step further. And that question is your hypothesis. I think this will happen. So you're going to test the hypothesis with an experiment. And that experiment is going to have an independent variable that you control, a dependent variable that changes based on that thing that you control. So in this morning's thing, the independent variable is how often you check that cup of boiling water that is turning to frozen. The dependent variable is the temperature that the water is, and that changes based on how long you wait. The controls are what stays the same between every iteration of that experiment, and the units are what you use to measure. So for example, this morning it was degrees Fahrenheit. Okay. So then once you have your data, you're going to analyze it and find patterns. A good way to analyze data can be to put it in a visual, like a bar graph, a line graph, a scatter plot, and it's important to look at what data is outside of that range. So maybe when we do our water absorption lab, maybe we have one thing that's just like absorbs like a crazy amount, and that might be due to human error, or it could be a really interesting question that will lead to more research, right? Or maybe we have one that hardly absorbs anything, and we want to know what that is about too. We want to find patterns of what's going on here. So once we've developed our experiment and done it, we need to communicate what we found. So one way that scientists do that is through the CER process: the claim, evidence, and reasoning. So the claim is, I think that, you're not going to start with I think, don't start with I think. You're going to say, paper towels are the most absorbent household material. And the evidence that backs that up is the data that you collected. The evidence is actually the easy part to collect because you already have it from doing the experiment. And the reasoning is the scientific principles behind why that's the case. So if paper towels are the most absorbent, why are they most absorbent? What do we know scientifically that gives us that knowledge? So this looks a lot like your flow chart that you did on Tuesday morning. Asking a question, do background research. This is the process of scientific inquiry. Right? Conduct a hypothesis, test with an experiment. Is it working? Is it not? If the experiment is not working, then you need to troubleshoot it and figure out a different way to conduct it. And that doesn't mean it's like agreeing with what you found out or not. It's just like, are you getting results that make sense in some way or another? Right? And then you're going to analyze that data. Sometimes those results are going to align with your hypothesis and back it up. Sometimes they're not, and that's also really useful information, because if it's not backing up your hypothesis, then that gives you a good reason to have a new hypothesis. Try something new. So then there's this activity that's just like a matching thing. Let's get past that. So here's our question: which household material is best at absorbing water? So that's our driving question. Which household material is best at absorbing water? Our hypothesis is going to be what is the most absorbent thing. So hopefully the item that you pick to test its absorbency is the most absorbent thing in your household that you can think of. Then we're going to design an experiment that will test the hypotheses. So on Wednesday in class, you wrote out a bunch of procedures that you think might work, and then we came together as a class to come up with our common procedures that we'll use when you do it on your own at home. And then we'll analyze the data, and we'll communicate our results there. Skip the question, skip the poll. Okay. So when we test our hypothesis with an experiment, our independent variable is going to be the material that we use. We choose what those materials are. So I'm in control, meaning not me personally, but the scientist is in control of what that material is that we're testing. The dependent variable in this case is how much water that material absorbs. Okay, so the control is going to be what did we decide as a class that we want to keep the same, and then the units is what are we using to measure. Is it teaspoons? Is it tablespoons? Is it cups? Is it gallons? What are we doing? Independent variable is the thing we are in control of and can change, so material. Dependent variable is the thing that we're measuring because it changes based on the independent variable. Skip the poll, skip the poll. So what are the controls in this case? So that's something that we kind of determined in our class procedures. What are we controlling for? You know, is it like how much water we're starting with? Is it the size of the material that we're using? I think all the classes decided we were going to use 3 inches by 3 inches for our material. So how do we measure the dependent variable? Yeah, again, are we using like tablespoons? Are we using cups? Are we using gallons, teaspoons, half teaspoons? What are we doing? Did we account for all the controls? Are we considering ease of use and that everyone's going to have the materials that we're looking for? Some people were talking about using a scale to determine how much water is there before and after. Does everyone have a scale in their house? Did we write this in a way so that others can easily do this lab and get similar results? It's really important in scientific experiments that your experiment can be replicable, that somebody could do the same thing and get the same results. So here's an example of a procedure for baking chocolate chip cookies. Okay, so when you write your procedures, which you already did today, but if you're coming back to it, you need a step-by-step detailed thing about how this is going to work. So here's a procedure for baking chocolate chip cookies. So your job on Wednesday is to write a rough draft procedure that everyone in our class could follow. And there's my son Max saying hi. Thanks for being here. Thanks for watching this video. We'll see you guys later. Bye.